Hello, this is Marie from ai-coustics, and today I will show you our Hugging Face space for our newly launched Quail Voice Focus 2 model. The model is specialized on isolating the foreground speaker of any background voice activity that can be background chatter in a busy cafe or an office, but also having a TV or a podcast playing in the background. The model is engineered for speech to text specifically. That means that the output is optimized for these STT machines and not for human perception, and it can be that it sounds a bit weird, but it still ensures the highest transcription accuracy, which is what the model is trained for. So now I will show you what you can actually try out in our space. First of all, you can pick an STT model. For now, you can choose between Soniox and DeepGram. If you clone our repo or use one of our other integrations, feel free to test out the STT model of your choice. The enhancement level parameter indicates how strong the enhancement of the output should be. If you set it to 0, basically nothing happens and the output of the model will be exactly as the input. If you set it to 100, the model is the most aggressive and suppresses the most background activity. We found out that around 80 is like the sweet spot for most of the STT providers, but this parameter should definitely be tuned to your special use case and the STT model of your choice. Once you set those parameters, you can choose between 3 different options: streaming audio in real time, picking a sample from a dataset, or uploading your own local file. For the streaming, you can also set the input gain parameter, which basically just increases your input gain. That can be helpful if you're far away from the microphone or talking quietly, because the model is trained on a special range of loops for the foreground speaker, and otherwise the speech could be detected as background. Also check out the docs for more information on that. To demonstrate the streaming in real time, I will just play a podcast with some speech in the background and explain what's going on and how our model improves the transcription. So if I hit recording, it takes a few seconds, but when it's ready, you can see my voice being transcribed. And if I add the podcast, you should see that on the left side only I am actually being transcribed, while on the right side also the guy in the podcast is transcribed. The reason for that is that for the enhanced transcript, only the enhanced output of our Quail model is fed into the STT, and for the raw transcript, the whole mic input is fed into the STT. So only for the left side, the background speech is being suppressed.
And more than that, if we could just get in touch with the Martians.
Another option to test our model is offline. You can either upload a local file or pick a sample from the Dawn Chorus dataset, our open source dataset containing many samples with background speech. When you click on the link, it will lead you to the Hugging Face site. I won't go so much into that now, but feel free to check it out as well. For now, we will just use the pre-selected sample, set enhancement level to 100. Soniox is selected. I will play the file for you once.
Yeah, it's a bit creepy, but yeah. Yeah, literally. I have a friend that had.
So you can hear a woman talking in the foreground and a man in the background. When I enhance it, you can see that the processing is starting, and it's dependent how long it takes on the length of the input as well as your internet connection. And now it's ready. First we will listen to the output.
Yeah, it's a bit creepy, but yeah. Yeah, literally. I have a friend that had.
So you can see nicely here that the background speech is cut out. You can see the same in the spectrograms. This is the spectrogram of the input and this is the output. The green marks is also some model output because we don't only output the enhanced audio but also some labels where their voice is detected or not, which are here labeled in green, and you can see that they strongly correspond to the foreground speaker. On the right side, you can see then the STT output. The ground truth transcription are human labels from our dataset, and then the noisy transcription is the Soniox output for the noisy audio or the input, and the transcription post-enhancement is the transcription from Soniox from the Quail output. You can see here that Quail reduced word error rate by almost 20%. Also note that different STTs behave differently on edge cases, so always look at the transcript and not only the word error rate. That's it for the Hugging Face space and the things you can try out here. We are also integrated in LiveKit and PipeKit, so you can easily integrate our model into your voice agents. You can also see in our documentation that we have language bindings for Python or C++ and other programming languages, so you can be creative and use the model in all different kind of applications.